Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our 20th lesson on a given Form 4 mathematics topic called differentiation. So we are looking at our 30th example, which reads that a farmer intends to fence off 324 square meter of his shamba for grazing. So the enclosure, which is rectangular in shape, is to be fenced on all sides. Determine the dimensions of the enclosure, which will require minimum length of the fence wire. So of course we start with the information that we are given. We are told that a farmer intends to fence off 324 square meter of his particular shamba. Of course, square meter, these are the units for the area. Then we are told that the shape is rectangular. Therefore we'll say the area of a rectangle, of course the shamba is rectangular, will be given by length, then of course multiplied by the width. Then we are told that this particular area is equivalent to 324 square meter. So from this equation we can say that length multiplied by width is giving us a 324 square meter. So I can make one of the dimensions to be subject of the formula. To achieve that, I'm gonna divide through by width. I also divide through by width, so that I can make length to be my subject of the formula. Therefore, I can say that the length of this particular rectangular shamba will be given by 324, then of course divided by W. So I'll let this to be my first equation. Then from there, we are told that the enclosure, which is rectangular in shape, is fenced on all sides. So of course, fencing on all sides means that it was being fenced on this side, that is the width. It was also fenced on this length, the other width, then of course finally the other length. So in short, they are telling us that they fenced the whole rectangle. Of course, distance around the figure, that is what we are calling the perimeter of that particular figure. So we are told that determine the dimensions of the enclosure, which would require minimum length of the fence wire. So a point to note is that the length of the fence wire will be equal to the perimeter of that particular figure. Since they fenced all sides were fenced around, it simply implies that the perimeter of the rectangle, the perimeter of the rectangular shamba will be equal to the length of the wire. This one is equals to the length of the fence wire, the length of the fence wire. So the distance around a figure, which is simply the length of the fence wire, will be equal to the perimeter of that particular figure. Therefore, we'll say that the perimeter of the rectangle P, since it was fenced on all sides, we know that the perimeter of a rectangle is given by 2 into then of course length plus the width. But because we already have an equation for the length, we can easily substitute. Therefore, we can say that our perimeter will be equal to 2 into our length is equivalent to 324 over W. So this is 324 over W, then of course plus the width. I'm simply substituting so that I can create only one variable on the right hand side of my equation. Therefore, the perimeter will be equal to, if I open this bracket, of course the 2, I'll have 2 being multiplied with 324 over W. Then of course the 2 is also going to multiply our W. Therefore, it means that on simplification, we're gonna get the following. Our perimeter P will be equal to 2 multiplied by 324. This one will give us 648. So this is 648. Then of course divided by W, then plus 2 multiplied by W, we are simply going to get 2W. Therefore, this is our equation for the perimeter of this particular rectangular shamba, which is used for grazing the animals. Therefore, we can also reduce this equation to P is equals to, on applying the laws of indices, we know that whenever we have 1 over a to the power of positive n, this is the same as saying a to the power of negative n. That is, whenever we take this one to the numerator, the sign of the power changes. Therefore, it means that this was power 1. So similarly, if I take this one to the numerator, the sign of the power is gonna change. Therefore, we'll have 648 then of course w to the power of -1, then plus a 2w. So I'm doing this for the purposes of easy differentiation. Now we are told that determine the dimensions of the enclosure which would require minimum length of the fence wire. This is another way of saying that which would require minimum perimeter, perimeter of the wire. Now we know that at any given minimum point or the maximum point, the gradient function must always be equal to 0. Therefore, we'll say that at the minimum length of the wire, at the minimum length of the fence wire, this is the same as saying at the minimum perimeter, perimeter, we know that the gradient function in this case, which will be d perimeter, the derivative of the perimeter with respect to the other variable is w, with respect to w must be equal to 0. Therefore, we're going to say that d over dw into the perimeter, which is 648, w power -1, then of course plus 2w, which is basically this equation. This must be equal to 0. That is at the minimum point or at maximum point. Therefore, on differentiation, of course, the power will pre-multiply the coefficient. Remember, whenever you divide with the w, dw, or dt or dx, this one is telling you to differentiate. But whenever you multiply by dw or dt or times dx, that will be telling us to integrate, as we shall see in our next topic. So the power will pre-multiply the coefficient. So we're going to have 648 multiplied by -1, then w to the power of -1. Then of course we subtract 1 from the power, then plus this is power 1, so the 1 will pre-multiply the coefficient, so we'll have 2 multiplied by 1, w power 1, we subtract 1 from the power, this should be equal to 0. So 648 multiplied by -1, I'll get -648, then of course w to the power of -1 minus 1, I'll get -2, then of course plus 2 times 1, I'll get 2, then w power 1 minus 1, I'll get 0, which is equals to 0. So this is telling us that this can be rewritten as the following. You can actually rewrite it this way. We can rewrite our equation. It means that our equation would remain to be -648 w power -2, then of course plus of course when you take w power 0, this one is going to give you a 1. Therefore this will be 2, then of course multiplied by 1 being equal to 0. Therefore -648 w to the power of -2, then of course a plus 2 times 1, you'll get 2, this one is equals to 0. So clearly we can say that I can take this one to the right hand side, so that 2 will be equal to a positive 648, then w to the power of -2. From the laws of indices, whenever I have a power -n, this is the same as saying 1 over a power positive n. So that means I can take this one to the denominator. So I'll have 2 being equal to 648, then of course divided by, this will be w to the power of 2. So I can simply make this a fraction so that I do what we call cross multiplication. So if I do cross multiplication, this will multiply with that, then of course 1 with that. 2 times w squared, this will give me 2 w squared being equal to 1 times 648, I'll simply get 648. Then I divide through by 2, I divide through by 2, so the 2 will cancel out. So w squared will be equal to 648 divided by 2, by 2 1, by 2 this is 3, then of course by 2 this is 2, by 2 this is 4. So w squared is equals to 324. Now, after getting our w as 324, we can now get the actual value of w. So to get the actual w, we're going to square root both sides of the equation. So I take square root, I also take square root. But remember, square root is plus or minus. So that means w will be equal to plus or minus square root of 324. You feed that on the calculator, your calculator will give you 18. Therefore, it means that the width will be equal to positive 18. The units were meters, meters, or the W can also be equal to negative 18 meters. But we know that with this is a scalar quantity, therefore you're going to ignore the negative part. Therefore, we conclude and say the width of this particular rectangular chamber will be equal to positive 18 meters. Now, they wanted us to find the dimensions of the enclosure, which would require minimum length. So the length will be 18 meters. That is the width. So you can also get the length. Remember, from our initial working, we had said that length times width was equals to 324, which was basically the area of this particular rectangular figure. So from here, we had said that the length we divided through by W, divided through by W. So clearly our length was equals to 324 divided by W. Since we already have the value of W, we can substitute to get the value of length. Therefore, our length will be equal to 324 divided by W, which we have gotten as 18 meters. Therefore, our length will be equal to 324 divided by 18. You are still going to get 18 meters. Therefore, the dimensions that will give, that will require, the dimensions that will require minimum length of the wire, or simply put the perimeter of the wire will be given by, we shall need a length of 18 meters and a width of also 18 meters. So the length of 18 and a width of 18 meters will give us the minimum possible perimeter. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to this channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.